good evening. Can I request everybody to please take your seat? Request everybody to please take your seat. I hope all of you now must have dropped your business card for the lucky draw. Can we have the ball, please?
Hello, hello. So friends, welcome back to the final session of Symposia 2018. So good, the probability increases now. Still people are having their tea, coffee.
Those who will not be present inside the hall will not be entitled for the prize.
Venkatji? Is he around? Yeah, please. Soni ma'am? Mr. Vikasji? Aye, Venkatji, please come. Guys, come on, a big round of applause for Mr. Venkat, please. Sir, ज़्यादा आवाज नहीं आए तो देना ही मत. Soni ma'am, please.
Saloni, speaker profile. The next one. Money profile. Where is it?
Okay, guys, so lucky draw starts. And those who miss out, they are lucky. Those who get, they are also lucky. Okay. Yeah. Venkatji, please do the honors.
Guys, please clap.
Come on. Mr. Jay Panchal, Johnson Controls. Vikasji, please upar aa jaiye. Mr. Jay Panchal.
Can we have Mr.
Come on,
Jai
guys,
Panchal?
let's give a big round of applause to Mr. Jay Panchal.
He gets the mobile, right? He gets the mobile.
All right, people, give a big round of applause, Mr. Jai Panchal.
Shall we remove one more? Yeah, let's go ahead. अरे वेंकट जी खड़े रहिए. आइए, please stay here. The next, would you like to announce? Yeah, please.
Mr. Ketan Sheth from Belimo Actuators, India. Mr. Ketan Sheth.
Mr. Ketan Sheth.
सर देखो ये सेटिंग की थी. ओके, मोबाइल मेरा, सिम कार्ड आपका. प्लीज, congratulations to you, please. Thank you. So you want to announce the final thing? Maybe at the end.
Yeah. We have only one more surprise gift or prize, or lucky draw, whatever you want to call it, is left, and it is the what you call biggest Alexa, which is a good prize worth approximately 16,000, and I believe that you all will like to bid for it. So please stay till the end, because we are going to announce it at the last. Whoever will be, his name comes in, and if he is missing it, it will be a very bad. So we just left some last 2 hours only, or maybe some very limited time. So I would request everybody to present and see, witness the last session and be part of the last lucky draw. Thank you.
Good afternoon all. Again, welcome to our crowd, a good crowd actually, quality crowd which I'm having, and we are very, very much thankful to you for giving your precious time to ISHRAE and our platform. So there's an announcement for your ISHRAE Thane chapter is going to conduct Energy Efficiency Summit on 14th of July actually. Can you change? Yeah. The venue will be Country Iron and Suits at Navi Mumbai. The Efficiency Summit cover all these things of the energy conservation policies, implementation strategies, building energy audit, variable primary system, advancement in the automation and new building, HVAC system optimization through effective operation and maintenance, testing, adjustment, balancing, which is the critical part in any HVAC system. So enroll yourself for 14th of July. Keep your time available, and contact person will be Priya from Thane Mumbai, Thane ISHRAE chapter. Miss Priya, you can search it on our ISHRAE website. Thank you. Thank you, everyone. Yeah, Kiran.
All right. All right, ladies and gentlemen, once again, welcome you all for this wonderful and last session of Symposia 2018. And the speaker is Mr. Manish Gokhale. Manish Gokhale is the Director of Business Development at Schneider Electric. He focuses on business development of the three-phase UPS, cooling, racks, and accessories portfolio of solutions from Schneider Electric IT division. Manish comes with a rich 22 years of demonstrated expertise in areas of business development, service operations, solution sales to the critical power industry. He has first-hand experience of interacting and providing solutions for the facility-wide solutions. He has been involved in providing turnkey facility-wide solutions for major data centers, industry, telecom, and service industry. He has handled various roles including country manager for telecom and services vertical in Schneider Electric. He is currently working as Director, Business Development. He is an alumni of Indian Institute of Foreign Trade and holds a degree of engineering specializing in power electronics. May I request everybody to please join your hands together and welcome Mr. Manish Gokhale. And he's going to speak on Hyperpod, the backbone of data center.
Sound?
Okay. Yeah. So good evening, everyone. First of all, let me start with thanking ISHRAE through the Symposia 2018 to give me a chance to present in front of this August gathering. I am really humbled from the morning, the type of sessions which we have been seeing, the amount of knowledge transformation, but much more important than that, in spite of a long haul, people are continuously paying attention. It's really amazing. So I should thank ISHRAE for organizing this. In fact, this is my first chance to speak at a ISHRAE session, and I strongly believe sessions like this are very well tuned with ISHRAE's objective of creating continuous learning opportunities for professionals in the heating, ventilation, and refrigeration industry. So I am first of all thankful to ISHRAE and request all of you to give a big clap to the ISHRAE and the organizing committee for organizing this. Thank you. So let me talk. So what I'm going to talk today, I'm going to talk today about a very innovative subject. Most of you would have heard something about Hyperpod. I'm going to talk about Hyperpod, which is a backbone of the data center. Now, when I say most of you would have heard about Hyperpod, I just casually did a search for Hyperpod a few days back to find out there is an article which is coming up of a pod in Hyperloop. That's something very often comes up. And today morning, one of the speakers did cover that. A pod in Hyperloop is a new way of transporting human beings in the future industry. That's the urban transportation system which many governments are considering right now. But today I'm not going to talk about that. I'm going to talk about an Hyperpod, which is basically a backbone of your data center. backbone of your IT in your data center. Even before I start, I would just want to touch upon one particular area, which from morning many speakers have spoken about. Most of our customers do agree it's very important, and I think all of you consider it as one of the most important paradigms through which efficiency of a data center can be optimized, performance can be measured, can be made predictable, and reliability can be increased. I am talking about segregating the air in the data center. Segregation of cold air versus hot air, what we commonly also known as containment systems. But we all know about containment systems, so I'm not going to stretch along, but before I start my presentation, I want to just remind you some of the things which many speakers have spoken in the morning. Reliability is increased primarily because there are no hotspots. Because you contain the cold air and the hot air in a different sections, it means there is much lower temperature which is sucked in by the IT equipments, so the probability of hotspots are reduced to a greater extent. Containment solutions increases the delta T, that is the difference between the cold supply air temperature and to hot return air temperature, what a cooling unit gets. In an uncontained data center floor, it is estimated that and uncontained and the very conventional data center with raised floor, it is estimated that close to more than 50% of the air, cold air, goes back to the cooling unit itself. It bypasses the entire system, and through which the method of leakages and other things, which compromises on the efficiency of the entire cooling in the data center floor. But if the same thing is contained, it has been observed by industry analysts as well as by customers and vendors that it is possible to revive and increase the cooling capacity by a quarter. Close to 20 to 25% of cooling capacity can be increased if just by shifting to a proper containment system in the data center floor. It also gives you an opportunity to increase the energy saving just by a simple segregation of hot and cold air. Now, it has been so prevalent in the industry, or at least what everyone has been agreeing to talk about containment. From today morning, almost everyone spoke about containment systems. In fact, today the debate is not whether there should be a containment or no containment. The debate is whether it should be a hot aisle containment or a cold aisle containment. That's what the debate typically happens. And there have been various methods on which this debate has been happening for last decade or so. Today, when we speak about anyone, is containment important? Almost everyone will uniformly say, yes, it is absolutely important. Does it increase the efficiency? The answer is yes. Does it increase the predictability in a data center? The answer is yes. Does it increase reliability? The answer is yes. But when we look at the containment systems, and when we start walking out in the data centers of the actual market, we go out and do a walkthrough of data centers, we see a completely different picture. Even though everyone in the industry agrees containment is must, what we see on the field, we see very less amount of data centers which are having a containment solution fully implemented. We still see racks of rows of racks properly arranged today, as 10 years back they were not even organized in a hot or cold aisle mechanism. Today they are much better arranged, no doubts about it. But when it comes to containment systems, suddenly, even though the customer also agrees, we don't see so many containment solutions being deployed in the market today. If you speak to industry analysts, they will also say that it increases reliability and efficiency. But again, they also admit that there are issues because of which customers don't actually follow a containment system. Now, we at Schneider decided to dig more into this particular simple approach to increase the efficiency of a data center. We went around the world, met thousands of customers, met consultants, met end users, met system integrators, and tried to find out what is the one reason because of which people are still not deploying the containment system. And there are a variety of answers which we received. This is one of the sample answers, for example, what I would want to share. This is from a co-location industry, because this is the industry we believe that most amount of improvements are possible by doing a containment system. The first and foremost question which customers keep asking is, it's too difficult to deploy in my data center environment. Can someone come and make it easy to deploy in my data center floor? That's a question people keep asking. There are other questions which keeps on asking, specifically on co-location, that most of the containment solutions today has to be done where existing racks are existing. There are racks and my tenants are there in case of co-location data centers. And they are not comfortable with someone working on tinkering and drilling holes and other things when my IT servers are on. So how do I integrate and do a containment system when all these things are available? They just want to have every infrastructure to be ready before a tenant arrives. It means there are no racks available, but they want to have every infrastructure available, including the containment systems. Are there solutions? We'll see. But these are the challenges. And finally, there is a growing trend in the co-location data center to mount fully integrated racks. It means it's an IT rack which is fully populated, either at the staging area of the data center itself, or there is also a new trend coming in where the tenants bring their own total populated racks and give it to a co-location provider. Here is my rack, give me a space, and we'll use your facility to do that. Now, that throws entire containment philosophy into jeopardy. These are some of the challenges. Let's look into more details of this. The basic issues with traditional containment systems are that they are not flexible. First, generally they get mounted on the IT racks. So you have IT racks, on that only it will start mounting it across. But we all know in a complex co-location data center space, you will have IT racks of varying heights. Worst is they might even change during the duration of the next couple of years. So that creates more complexities. You have server storage, storage racks, something which is of lower height. IT server can hide up to 52U also. How do you contain all these things? That becomes a problem. It doesn't easily accommodate varying rack sizes. It becomes extremely complex. More importantly, it 100% requires cutting and drilling on site. No IT manager or your customers who is mounting the things in a data center floor would like anyone to come on the floor and start working on it. Forget about drilling and cutting. And that is the reason why even in smaller data centers, even though people agree that containment is absolutely fabulous thing to do, people don't implement that at site, even at the expense of spending more energy. But these are one of the things which we have observed. Second thing, I discovered fully integrated IT racks. Now, 10 years back, most of our data centers used to build up, they used to place empty racks in their white space. Today, it's no longer the case. Earlier, people used to just bring their servers and mount into the IT racks. Today, people bring their own IT racks along with mounted equipment. It means your containment solution strategy, containment strategy goes for a toss. Second thing is, if you allow that thing to happen, you essentially would mean that you will have to do containment after the racks are in place. Again, the same question. Will the customer be comfortable of someone working on that particular floor? When my IT racks, forget, there are simple instances because the people who work on these containments may not even understand the complexity which goes on in IT server at that moment of time. I'm not talking about thefts, which can also be a possibility when such a expensive infrastructure is in place. These are some of the challenges. Can there be a solution to this? One of the possible solutions is instead of having a containment mounted on the IT rack, we mount on a freestanding floor. So that could possibly take care. But is it? Is this the only answer? The answer is no. There are much more challenges which are being faced. Lastly, some of the other challenges is deployment is something very hard. We all discuss about raised floors. It's absolutely important. And I think most of the people in this room at least would agree they are not very comfortable with thousands of cables below the raised floor. We are all from cooling industry. We know the complexities and the obstruction to the airflow, what it can happen because of so many cables and infrastructure below the raised floor. But there is no choice. That is what is happening today. The infrastructure is built up in that particular fashion. So there is incorrect use. The ceiling suspended solutions are available, but again, if you have an existing data center, you have to go and start drilling it. It's also very expensive and intrusive, much more important. So these are some of the challenges, very simple ones. In fact, one more challenge which has been observed is people have found ways to do that. So we start doing a containment design based upon measurements given by an IT manager or approximate space. And when you actually land up deploying this, you realize that a pillar which is there inside the data center floor is just 5 mm offset. And that changes your entire containment design, and it goes for a toss. And that is where we see most of the practical problems coming up while deploying a containment system in the industry. So we started thinking about it. Is there some way of improving? Because we can't just work like this. It can't be. It's the most basic thing which a customer can do, which a vendor can do, which a consultant can recommend, is to have segregation of hot and cold air. But that itself has been made so complex. And that is where our team came out with an interesting proposition. And we are calling it HyperPod. What exactly is HyperPod? It is a rack-ready system designed to deploy IT. And you will see why do we call it as a backbone of an IT system. First, let's look at what benefits it allows you. It is very flexible. It allows today's customers to roll in or roll out IT racks without disturbing anything, which is not possible in the conventional design methods. It allows for quick installation of containment even when there is no rack available. So we will see how it is done. And finally, it's no longer a construction project at site, it's an assembly project. Now that are two simple words, but that changes the entire way everything is deployed on the site. So these are three major benefits. Let's look into these things in much more detail. On the first one, the flexibility side. Containment and HyperPod is basically based upon a freestanding structure. So this is a freestanding structure which we are talking about. It is based upon that. So theoretically, you can just place it without any need of any support systems in place. It can start mounting it itself. A containment is built around that, and it is attached to these frames. And these frames are not simple frames, they are telescopic frames. It means you can adjust the width as you want. You can also adjust the depth of the aisle as you want. So it means there are certain variations to that. It is possible to adjust it without doing costly construction projects. It can also possible to have mix of IT racks. You can have a 52U rack and a 42U rack in the same particular things through standardized components, standardized partition which can be placed into that. It is possible to do that. Finally, it is available for single rack as a single pod, 2 pods, as well as for multi-pod. So it's not that you can do only for a certain number of racks. It can go on multiplying itself in a much faster manner. It's very easy to deploy. So it's extremely flexible in terms of type of racks concerned. If there is no rack, there are standard frames available which can contain the air inside. It's absolutely flexible in terms of rack deployment is concerned. Cooling. Whether you are buying a perimeter cooling or you are buying an in-row cooling or inside room or outside room cooling, we have discussed so many cooling options from today morning. Any type of cooling options, HyperPod is compatible with. More importantly, it can be deployed for hot aisle or a cold aisle. There is no limitation for that, based upon your choice. Every customer has its choice and preference towards a particular type of containment systems. And HyperPod gives the customer the choice in their hand. And finally, the roofs, there can be simple or drop-out roof options, and options of horizontal vertical ducting is available. So it's multiple options and flexibility is there in terms of cooling also. Let's look at the power. It's compatible with connecting either row-based power solution, which sits at the power distribution at the end of the row, or within the row, in-row power distribution, it is compatible with. It can also take care of busway systems at the top of the racks. More importantly, through a flexible and extended cantilever systems, you can mount all the cablings here. You suddenly don't need to have ceiling suspended cable trays for a data centers, or even the cables are not required to be taken from below the false roof. This is a self-contained system in its totality. So lots of flexibility is available into this. Let's look at whether it's possible to do it much before the IT is delivered. As I said earlier, it is no longer a construction project. It's more of an assembly. So there are standardized components which can be ordered and can be deployed like an assembly of multiple components. I discussed about power cables, but there is flexible space available for data cables as well. So it's really emerging as you deploy a backbone of infrastructure through which you can route your power infrastructure, your data and network cabling, the cooling infrastructure, the piping, chilled water piping, as well as other things can be routed. You can have distribution systems into that particular pod itself. What it really forms, and without even having a single rack at its location. And there are flexibility because it can vary very easily. And that is the reason, in a co-location space specifically, it is possible now to have this hyperpod in place, keep it ready with all the cabling done, power as well as data cabling done, and tenants can just bring in their IT racks, maybe fully populated, and just plug in directly into that. That increases the amount of flexibility by tremendous extent. And you don't need to do any work on this particular unit at all. So that's something, a flexibility which the hyperpod is able to offer you. Finally, there are few more benefits. No ceiling suspended cable trays, no cables below the raised floor. It supports power, fiber, copper, ducting and piping. Everything it supports. What is really forming about, and this is the only reason why we call it the backbone of your IT systems on the white space. Now this is something which is absolutely important for us. So you can replace the ceiling suspended one through this cable trays here, which comes as a standard accessory based upon the solutions. The data cabling, there are separate provisions on the right side which is available. So this becomes an entire infrastructure for your IT equipment in your data center. I'll just take you through a small video and then we'll take this further.
There is an increasing trend of IT being deployed rack by rack rather than server by server, scaling at the largest increment possible. Data center customers are deploying simplified, cost-optimized data centers, and high-efficiency operations has become standard practice. Large enterprises are quickly adopting new open compute-style architectures and changing the data center landscape. HyperPod addresses these trends. This new offer allows data centers to be designed, deployed, and upgraded faster and at a lower total install cost. We have leveraged our work performed for data center customers and use this experience to develop a highly customizable pod framework that can support various applications. Businesses can preserve cash by rolling out pods as needed. Our pod solutions support new OCP and converged architectures. The pods are constructed of materials that do not require field cutting or drilling and are assembled with simple or no tools. Deploying pod infrastructure is more like an assembly project and less like a construction project. Pods are not partial to any specific power distribution method or cooling technology and integrate to all methods equally well. Racks are able to roll into and out of rows. Fully converged racks can be connected, powered up, and running in a matter of minutes versus hours. The frame itself provides out-of-the-box support for open compute-style architectures. Plug-and-play software management and physical security options complete the offer. Pod-level designs facilitate deploying at scale. These solutions dramatically reduce the amount of physical data center construction, allowing pods to be deployed in parallel with IT. We have future-proofed data center physical infrastructure for larger deployments. Designed for data center customers, HyperPod makes data center deployments simple, fast, and cost-effective.
Of course, we are all interested to know how much cost or cost effective the solutions are. And that's the reason why I wanted to take you through this particular analysis which was done by our data center science design team, wherein we looked into at this typical data center of 1.3 megawatt with 9 pods, of each pod of 24 racks each. And I'm not including here the cooling cost and the power cost. That's not, that is the cooling equipment and power equipment is not included into that. But these are the configuration which were looked into right from data cabling, power cabling, distribution paths, and all those particular things were discussed. air distribution was through raised floor air plenum, and containment was cold aisle containment. That is very typical of a co-location data center. Some of the more things which were taken into consideration was hyperpod was frame-based as well as conventional containment mounted on the IT racks type, so for example, and these were some of the considerations taken up. Now, when you look into these two types of things, these are very common. The traditional infrastructure is very commonly deployed, and you would agree it's seen normally in the industry. And hyperpod is a new innovative method of doing all these things together. Let's look at, is there really some capex saving which is happening because of deployment of hyperpod? We believe so. Our analysis shows that it is possible to do that. And this is a waterfall flow of all the costs what you incur in constructing a raised floor. Right from containment cost difference, which is the basic, but whether it's, you don't require a ceiling grid construction, you can reduce the raised floor height. It's possible to do that because it no longer has to carry multiple things inside. Frame cabling supports, reduce networking ladders, simple things like the power whips, that is the distribution cables from the distribution box to the servers. That is reduced dramatically because you have a distribution unit mounted on the hyperpod itself. So those are differences. Our analysis show that there is close to 16% cost savings, which is possible by deploying the hyperpod solution, which is phenomenal. This analysis is typical. Details are available in one of the white papers, which we can share to you, and you can go through in those details calculations how this has been arrived. But it also reduces deployment time by more than 20%. This is huge. Benefit is huge, and we are not talking about a deployment time taken up for deploying the IT, which will bring in additional deployment time reductions. Because here you can deploy this particular things parallelly when you order, or your tenant is going to give you a schedule of bringing the IT racks into. So before they bring the IT racks, your hyperpod is ready. So for that moment of time, close to 21% savings, close to 18 days savings, which is being organized here. You can start getting the revenues much faster in case you are a co-location provider. These are two benefits which come into that. Quickly, some of the examples of this, you saw some in video. The first one is short frame. You can go for only containment. It doesn't give you any other options. Other options can be added on at a later date. That's possible. But you can order like this, or it can be short frame contained with mini cantilevers and cable tray. A mini cantilever is for only the data cabling, or you can go for with power raceways, which is available, which is last particular options. In fact, the beauty of this entire solution is everything is in a standardized part which is available. You don't need to redesign things. You have to just assemble those particular things at the site. Single pod, double pod, triple pod, in fact, multi-pod are possible. So based upon the length of the aisle which is available, you can select this. Of course, the moment you go for more than triple pod, a special engineered solution is required. But because of flexibility in the design, you can engineer that on a configurator tool and then go and deploy at the site rather than doing cutting or drilling at the site as such. In summary, for a single pod, which is available, you can vary from 8 to 12 feet. It can vary. The aisle can vary between 3 to 4 feet. Continuously, it can be varied. So we have seen practically that when you take measurements on the paper and design things, and when you actually deliver it, there are few mm of gap which is there. Now these gaps can be easily adjusted in a hyperpod. You don't need to redesign things at all. Doesn't matter that your original design was for 42U and you have gone for 52U. If it is part of your plan, it's possible to even accommodate a higher or lower IT cabinet, which is possible. Doors, types of roofs, tremendous amount of flexibility available. You can go and select what you want. And that is the most beautiful aspect of the entire hyperpod experience, if I would call it. It has simplified the containment or deployment of containment to a very like Lego blocks. You just bring in different blocks and start assembling it at site. That's how actually hyperpod is going to simplify the way containment systems will be deployed in future. So key takeaways quickly. By deploying hyperpod, it's possible to design a data center where you can roll in or roll out IT racks very easily. This is what the demand for today from the IT managers, from the co-location suppliers, is that they should be able to roll in, roll out the racks. It is possible to deploy the IT pods in a much quicker manner. It avoids costly and invasive construction, rather you assemble at site, and more importantly, it is 16% cheaper to deploy at site and takes significantly lower time for deploying the entire thing. There are more inputs available on our websites. You can go and study much more in detail. There are white papers available on deployment of different IT pod architectures. We are discussing not on particular architecture there. It will give you in-depth information of all types of pods which are prevalent in the industry, and what are the pros and cons of each particular pods. A beautiful tool is available, which you call as trade-off tool 23, wherein you can go and do an IT pod sizing. You don't need to depend. You can just go and click on the tool, fill in your information, what you're designing, and it will give you an estimate of IT pod. So that's something which is possible. And finally, of course, if you're designing a large data center, you can utilize this beautiful document, what we call as a reference guide. Now, this is for a 5.2 megawatt pod-based chilled water solution of 85,000 square feet. So this is a reference design. This is not an actual design, but it will give you the ideas about what to look into while designing the things, what should be considered. So the reference designs can be looked into in any one of these particular websites. And these are free. These are available for free. There is no charges for that. In fact, there are much more white paper sections which are available. This is 23, trade-off tool number 23. So it means there are 22 more. In fact, there are much more trade-off tools available. On each aspect of your data center designing, there is a trade-off tool available, which will help you right from estimating the cost of data center to selecting what type of cooling is best for you to the IT pod sizing calculator. So that's it for me from the HyperPod. I'll leave you with one small video, and then if there are any questions, I'll be more than glad to answer that. So thank you. That's it from me. Thanks a lot.
All right, thank you so much, Mr. Manish. Now I would request Ms. Sangeeta Jangiani to please come over the dais and felicitate Mr. Manish Gokhale. All right, ladies and gentlemen, we'll come over to the last speaker of this evening, Mr. Tushar Vedikar, Associate Director, Idea International India Private Limited. Tushar Vedikar is the Associate Director of Idea International Industrial Design Associates, is a building service engineering consultancy that specializes in the design, construction management and testing and commissioning of building services for commercial, corporate and mission critical facilities. A degree qualified mechanical engineer with 10 plus years of solid experience and strong track record in design, installation, project management and testing and commissioning for MEP services on projects throughout India and Asia Pacific region. Tushar Vedikar has executed several testing and commissioning projects for large and high density data centers across India and Singapore. The topic to be discussed all about data center commissioning. I would request everybody to please join your hands and welcome Tushar Vedikar.
Excuse me. Can you open the presentation? This is not mine. I didn't. Okay.
Hello everyone. Good evening to all of you present here. Firstly, I would like to thank the organizers to allow me, to give me this opportunity to present a very important subject for today, which is all about data center commissioning. The contents which I would like to go through today is commissioning goals in a data center, commissioning processes to be followed in data center, sample equipment test methodology, heat load test, and integrated system test. Data center. So we all, and there are many presenters who have told the importance of data centers, but we all know that data center is a mission critical facility, which means a single failure could result into heavy economic losses. And that's one of the reasons why many design consultants, they ensure they design the data centers with tier 3 and tier 4, which means they're trying to add multiple layers of redundancy, which is pretty good. However, there's one thing that ensures that whatever you design is correctly implemented, correctly validated, correctly documented, operated, maintained, and that's commissioning. So commission sure that it meets the design intent or the design cause and effect. The second goal of commissioning is to ensure there is absolutely no single point of failure, not just on paper, but practically on site. The third and the most important goal of commissioning is that it ensures or greatly prevents any unplanned shutdowns. Now, think of a situation where you have a fault in the system and you are not able to identify that fault during the project stage. It is very not just during projects, but during operation as well, because you're trying to follow a very standard process for commissioning, which ensures that every single step that you take during construction, it's safe and it prevents any hazard. And finally, the last goal is to achieve LEED credits. Now, LEED understands the importance of commissioning, and that is one of the reasons why they have allocated 2 points for testing and commissioning. One which is a prerequisite, which we call it as fundamental commissioning, and one which is a credit, which is we call it as enhanced commissioning. So these are the goals of commissioning for data centers. Now, data center being a critical facility, it is important that we follow a very stringent commissioning process. So let's understand the commissioning process. Let's take an example of one single project. We would like to divide that project into 8 levels. Level 0 is program and review. Level 1 is factory acceptance test. Level 2 is quality inspections. Level 3 is startup test and procedures. Level 4, functional test. Level 5, integrated system test. Level 6, turnover and handover inspections. And level 7, commissioning closeouts. So let's understand each step one by one. Level 0, which is program and review. Now let's understand the initial stage of any project is concept design, detailed design, and tendering, right? It takes approximately 6 to 8 months depending on the scale of the project. Now, the first thing that you have to do is to form a commissioning team. The moment your project starts, normally the owner is quite busy, so what he does is he appoints a third-party commissioning agent to lead the commissioning team. So we need to have a third-party commissioning agent who will represent the owner. Then you need to have representatives from the service provider, the representatives from the PMC or the project managers. These people, they form a commissioning team. That's the first step of level 0. What's the second step? The second step is the moment your design starts developing from concept design to detailed design, and once you understand the design, you have to now start producing commissioning documents or testing and commissioning scripts. Now this scripts or these method statements, they provide step-by-step guidelines of how individual systems or individual equipment has to be tested, and they will provide the acceptance criteria or passing criteria for each equipment. Now, why we do it at such a very early stage? The reason to do this commissioning scripts at a very early stage is because you want this documentation to be part of your tender package. You really don't want an argument during the construction stage or a fight with the GC that I have requested for 8-hour burn-in test of a generator, and he says, no, I'm not going to do it. It was not part of my scope of works. So it is very important that all these commissioning documents, they form part of your tender package. And that's one of the reasons they have to be produced right at level 0. Now, the third thing that we have to do is, the commissioning team has to do a design peer review. The design consultant's job is to produce design documents like drawings, BOQs, specifications, and the job of commissioning team is to review those drawings. Now, why we have to review this drawing? We have to review it from a commissioning point of view. Like, the first thing we have to ensure is that the design captures all the commissioning requirements. Like, you have the right number of load bank breakers, you have the right size of load bank breakers, you have allocated a space for the load bank, you have the right amount of balancing valves, a right amount of chill water test points. All these are related to commissioning points, and we have to ensure that all these commissioning requirements are captured in the design. So you don't have to wait till the construction starts, you can take care of this right at the design stage. The second thing when you are reviewing a drawing is, see, being part of the commissioning team, being done a lot of jobs, we understand the practical issues that could be created because we have done too many jobs. So a commissioning team can provide value addition in the design by suggesting the design consultant or the design team that if you follow this route, it could result into a certain practical issue, so we can avoid it. So the commissioning team is trying to provide value addition to the design. They're not trying to disrupt it, but they're trying to provide some value addition to the design, considering their practical experience. Okay, so that was about, the third point was design peer review. The fourth point is commissioning schedule. Now, I'm sure that many of you have seen a project schedule, right? At the end of the project schedule, just before the handover, you could see a duration of 10-15 days allocated for testing and commissioning. Do you really think that that's a practical schedule? No. The reason is the commissioning or testing and commissioning does not happen only at the end of the project. Commissioning starts the moment your construction starts. There are certain sequence, certain duration that has to be followed at every stage of construction. So a commissioning team comes into picture and ensures that they produce a commissioning schedule which is very practical and in line with your master schedule, and this commissioning schedule in turn can be incorporated into your master schedule. This makes your master schedule accurate and more practical. And that's the job of commissioning team. 1, to produce testing and commissioning scripts. 2, to produce a schedule. And 3, to do a design peer review. And that's level 0. Then comes level 1, which is factory acceptance test. The moment you're out of design, the moment you're into the construction stage, there are some critical equipments that we have to do or we have to go for a factory acceptance test. Now, what are those critical equipments? Those are chillers, PDUs, UPS, precision air conditioning units, switch gears, HT switch gears, transformers, etc. So all these critical equipments, we have to verify their performance at a very beginning through a factory acceptance test. The job of the commissioning team is to ensure they produce the right scripts, they witness the test, they issue out reports, and they have the authority to provide dispatch clearance for the equipments. Only when they're satisfied with the performance of the equipment, or they have the right to provide dispatch clearance. So that's level 1. Then comes level 2, which is QA/QC, which is quality inspections, quality checks. The moment you jump into construction stage, you have a lot of equipments which are getting delivered on site. You have a lot of installations which are taking place, like the tray installation, chill water pipes installation. Now, it is job of the commissioning team to regularly do site visits, ensure the quality is correct. Now, think of a scenario that you have spent so much of time and money to do a factory acceptance test of a certain equipment, and that same equipment gets delivered on site. It's some other equipment which gets delivered. It would be disastrous because you have spent so much of money and time, and you don't want that to happen, right? So A proper quality inspection and checks would ensure that such issues don't arise. You have the equipment placed at the right location, the right equipments are delivered on site, and the quality is, we have a continuous check on the quality of construction. The next step is level 3, which is startup test. The moment you feel, or the moment you are satisfied with the installations, it is time to energize an equipment. It could be energizing a switchgear, energizing a crack unit, energizing a PDU. The startup test is a step before you start your rigorous functional testing of individual equipments. Once you energize an equipment, it is very important you do certain basic steps, follow the process or procedure laid down by the OEM, and verify certain basic parameters. It could be verifying the voltage, verifying the phase sequence, verifying if the fan rotation is in the correct directions, etc. So basically, you're just verifying certain basic parameters before you jump to a full rigorous level 4 functional testing. Then comes level 4, which is functional testing, which means I'm verifying the performance of individual equipments and system. I'm trying to load the equipment to its full load condition, partial load condition, verifying the parameters and acceptance criteria. So basically, I'm verifying every single piece of equipment and system, and that's level 4 functional testing. The moment you complete your level 4, you will jump to level 5, which is integrated system test for a data center, which is the very critical and the most important step of commissioning for a data center. Now, you cannot jump to level 5 integrated system test unless all the issues that you have identified during level 2 to level 4 are mitigated. It's a prerequisite, a pre-test condition. So level 5 is basically divided into 2 parts. The first part is heat load test, and the second part is integrated system test. I will go into details of it, but let me first complete the process. Once you have a successful IST, then you are jumping to level 6, which is nothing but turnover inspection, which is an official handover of the facility to the operations team. This inspection includes verifying, the commissioning team will verify the O&M documents, they will verify the as-built drawings, and they will also verify if every single equipment is kept at the right design conditions. Because when you do so many testing activities, you tend to change the set point of the equipments. You change the set point of crack units, you change the breaker settings, but you cannot hand over the facility in similar fashion to the operations. You have to ensure that before you hand over the facility to operation, all the equipments are at their design conditions. All the breakers which are supposed to be normally open are normally open. All the breakers which are supposed to be normally closed should be normally closed. So that's a level 6, an official handover to the operation team, and it has to be rightly documented. And finally comes level 7, which is commissioning closeout, which is the end of the project. Commissioning closeout is nothing but whatever you have observed throughout the project, you have to list it down in a summary report. You have to produce a commissioning summary report that highlights what were your major observations and what were the steps you took to mitigate those issues. It could also include some lesson learned, some recommendations for future projects. This summary report in turn has to be signed off by all the relevant parties, including owner, commissioning agent, PMCs, subcontractors, contractors, etc. So that's all about a commissioning process that we have to follow for data centers. Now let me take you through some of the sample functional testing of some of the critical equipments. I have picked up 3. One is UPS, generator, and precision air conditioning unit. So let's see how we verify a UPS performance. So if I have to verify the performance of UPS, I have to ensure that I take following steps. The first thing I have to verify is I load the UPS to its part load condition and verify its efficiency. I will load it to 25%, 50%, 75%, and I will verify it provides the efficiency as mentioned in the technical catalog. The second thing I will do is I will load the UPS to its 100% capacity, and again I will verify the input-output parameters and verify it gives the right efficiency, what has been stated in the technical data sheets. The second point is overload test. All the OEM claims that their equipment can handle overload for a certain duration. So it has to be verified, right? So we will verify a UPS for 110% of its capacity. The third is transfer test. which means the UPS, we can transfer from mains to static bypass, from static bypass to mains, mains to battery, battery to mains. That has to be verified. Step load test or transient test, battery backup test, pre and post battery voltage and impedance verification, burn-in test at full load condition, thermography, and UPS parallel load test. Now let's understand it one by one. Let's understand step load test or transient load test. When you have an equipment which is at zero loading condition and you suddenly put a load of 50% or 100% to a UPS, you can observe following. You can see here the output current which is below. There was no load and suddenly you put 50% load. And then you have to observe the output voltage. You would see a small distortion at the output sinusoidal waveform. You have to ensure that the output voltage is not impacted. When you do this step load test, it is important to identify that there is no major distortion or break, because that would be disastrous for a data center. So it is very, very important to verify the step load test at 0 to 50% condition, 0 to 100% condition, or 50 to 100% condition. Let's take example of a transfer test. When we are trying to transfer, when there is a mains failure, when the input supply to the UPS fails, it jumps to its battery, right? During this transfer, it is very important to capture a waveform that shows that the input current was pretty good. Suddenly the power fails, the input power supply was dead, but there is absolutely no impact on the output supply. The output supply was intact, there is no break, which means the performance of UPS is great. Similarly, you have to verify the UPS performance when it transfers from inverter to static bypass and verify that the output voltage is intact, there is no break, there is no major distortion. Then comes the burn-in test, which is the most important or critical test for a UPS. You have to load the UPS to its maximum capacity and run it for certain hours. We can run it for 4 hours, we can run it for 8 hours. With my practical experience, what I've observed is the major failure of UPS could happen during this burn-in test. Out of 50 UPS, at least one could fail. I mean, I don't claim it, but we have seen it in past, that during the burn-in test, when you load a particular equipment to its maximum loading condition, there are chances that there could be a weak link which could result it into a failure. So burn-in test becomes a very important part of a UPS performance verification. Finally, thermography. So when you are loading a particular equipment to its full load condition, and if there are any loose links, it will get identified through a thermography test. Or when you are doing a UPS battery discharge test, it is very important to verify the temperature or thermal conditions of the battery during the discharge conditions. And it is through my practical experience I can say that I have identified out of number of UPS that we have tested during the battery discharge test, we could identify 5 to 10 batteries which are faulty and have to be replaced. If you don't replace faulty batteries, it could drastically impact your battery backup time. So this was some of the example of how we carry out the performance test of a UPS. Now let's take example of a generator. So if I'm trying to verify the performance of a generator, I have to ensure that I'm doing following checks. I'm verifying the startup checks for engine and alternator. I'm doing the alarm verification for generator. I'm verifying its performance during part load and full load condition. A step load test, which is one of the, it's a very critical stage step for a generator verification. Step load test from 0 to 50% or 0 to 70%. Then comes the burn-in test at full load condition and thermography. Step load test. You might have a very good design. You might have a transformer which is supported by an independent DG. But think of a scenario where the entire load is transferred from transformer to generator in one single step. Normally, if you speak to the generator suppliers, they would say that our generator cannot take more than 70% step load at any given point of time, which means it is important to verify this particular parameter. So when I am doing a step load test from 0 to 70%, I am verifying the frequency. And you can see here there's a deep in frequency of 7% and the recovery time is 4 seconds. So there are certain guidelines that has been laid out so by electrical codes that says that what should be the deep in the frequency and what should be the recovery time. So this particular test is very important when you're verifying the performance of a generator. Again, burn-in test, it is similar to UPS. Many failures, or some of the failures could normally take place during this particular testing, which is burn-in test at full load condition. Let's come to precision air conditioning units, or we also call it crack units. So if I'm verifying the performance of crack unit, I have to ensure that the following steps are verified. The first thing is design set point verification. What are the set points you're putting for temperature, relative humidity, alarms for temperature, high temperature, low temperature, alarms for low humidity, high humidity. So you have to verify those design set points. The second part is electrical parameter verification. You have to ensure what's the power consumed by the compressor, by the fans, by the heaters, by the humidifiers. So you have to verify all these parameters as part of electrical parameter verification. Then comes sensor calibration. You have many sensors, right? In data centers, you could have multiple supply air sensors, temperature sensors. You have a return temperature and humidity sensors. You have to ensure that those sensors are giving you right readings, right? The tolerance limit should be plus minus 0.5 or 1 degree Celsius maximum. If the tolerance limit is more than that, it means the sensors have to be calibrated again. Then comes the alarm verification. You have to verify the alarms. Controller operation checks. Now, the crack unit has an inbuilt program, right? You can verify the logic of how the cooling gets triggered, how the heating gets triggered, how the humidification or dehumidification gets triggered. So you have to verify this logic. For some of the crack units which are with dual coil, you can verify some extra logics like how the dual coil works in an alternate mode, in parallel mode, or in cascade mode. So this is part of the performance verification, which is controller operation checks. Then you can verify the airflow rates. You can verify the temperature and the chill water flow checks. These days you have an inbuilt ATS, so you can verify the changeover from primary source to secondary source, an auto changeover system. And then finally, time and failure sequencing. So this is basically the test that has to be carried out for a crack unit on site. Now let's jump to the heat load test. Now heat load test, as I said, the integrated system test is divided into two parts. The first is a heat load test, and second is an integrated system test. A heat load test is very important because you're trying to create or simulate an actual scenario in the data hall. So the purpose of heat load test is I have to verify the thermal condition of the data hall in cold aisles, in hot aisles, at the return side of the crack, at the supply side of the crack, during partial load condition as well as during full load conditions. So basically I'm verifying the temperature profile of the data hall at partial and full load condition. The second point is, or the second thing is, I have to verify the thermal conditions of the data hall during different modes of operation. It could be a hot standby mode, or it could be a cold standby mode. We'll see how it works. And throughout the heat load test, we have to ensure that the temperature and the relative humidity, they are not crossing the SLA limit provided by the owner. And of course, when you do a heat load test, you have to keep a very close eye on the chiller plant, of how the chiller plant behaves when you start loading your data centers. So let's have an example here. Let's assume we have a data hall with multiple racks, with cold aisles containment, and the crack units at the periphery, which is how you traditionally design a data center. Now, the way I will start my heat load test is, the first thing I have to do is, I have to place heat banks. Now, each of these heat bank will represent one single rack. So if my data hall is designed for 10 kilowatts per rack, I would have one heater of 10 kilowatts placed at the location of the rack. So if my data hall is designed for 1.5 megawatts or 2 megawatts, I will place the same number of heaters that can generate 1.5 to 2 megawatts. The second thing I have to do is, I have to create a temporary cold aisles containment. You cannot simulate a heat load test without a temporary cold aisles containment because you have to verify the temperature profile. So this is some of our existing projects where we have done a mock-up heat load test, and this is how it should be arranged. Now, the first, the test, the way I have to proceed is, I can start with the hot standby mode, which means, a hot standby mode means all the crack units, whether you design it in N+1 configuration or you design it in N+2 configuration, hot standby mode ensures that all the crack units are running. So I can run all the crack units and I can start loading the data center from 25% to 50% to 75% to 100%. And throughout this number of hours that I'm loading the data center, I have to keep a close watch on the temperature and the relative humidity in the cold aisles, in the hot aisles. Now, the second thing I can do is I can try to simulate the same thing in a cold standby mode, which means if I have designed my data hall with N+2 configuration, I can choose any 2 crack units and I can put them into standby mode. So if I have 12 units, 2 units will be on standby and 10 units would be running. And I can create multiple scenarios here. I can switch off the extreme end crack units, or I can switch off some of the crack units in the middle, or I can even switch off the crack units were next to each other, just to verify what could happen, or just to verify the thermal conditions at different scenarios. So this is how you do a heat load test. Once you do a heat load test, you have different sensors, right? You have temperature sensors, humidity sensors across cold aisles and hot aisles. I will collect all the data. It's important to collect the data and create graphs. So I will create a temperature graph and I will create a humidity graph, and then I will verify how was the temperature across the data hall during all these scenarios, and I will verify that it was a bit straight line and it was within your SLA limit. So here the temperature was between 20 and 25, which was within the SLA limit, so I can say that yes, the performance of the thermal conditions were within the acceptable limits. Same goes for relative humidity. So if I'm designing a data hall to a maximum relative humidity of 70%, at no given point of time, your relative humidity should cross 70%, because that will be a breach of SLA. So it's very important to create graphs, analyze them, and decide whether your test is passed or failed. During the heat load test, you have to very closely monitor the power. Like I started with 25%, then I jumped to 50%, then I jumped to 75%, and then I jumped to 100%. And throughout the heat load test, the power was intact. There was no dip, no drop of load. It was intact. It is a smooth line. So when you're verifying the thermal conditions, at the same time, it is important to verify the power. Okay, we cannot neglect that. Again, when you're verifying the heat load, you're doing the heat load test, it is very important to verify the central chiller plant. How do we verify? So when you're loading the data hall from 25% to 100% load, you have to see the behavior of chillers and see how the chill water temperature behaves. Is it stable? Is it rising? Was there a temperature which is more than your acceptable criteria? You have to verify that. You have to see the chiller loading. You have to study the chiller plant and then decide whether your chiller plant is able to take the load and behave the way you have design intentions are. Thermography. You could not get a right movement to do a thermography test for the complete MEP system. This is the right movement to do it. When you are doing heat load test, you're actually loading the entire data hall to its maximum condition. What I can do is, I can load my complete source A system on, let's say, 1.5 megawatts. When I'm loading my complete source A system, I'm loading my transformer, my switch gears, my UPS, my PDU to its maximum loading condition. This is the time when you can verify if there is any weak points or weak links in your system, and you can identify it through a thermography. Similarly, if you have verified it on source A, you can transfer the entire load on source B, run it for a certain hours, and again verify the thermal conditions through thermography. Now, what could go wrong in a heat load test? There are two things we normally observe what could go wrong. First thing is a lot of fluctuations in the temperature. Now, this is a temperature graph that we have created for one of our projects, which we have observed. This issue is called as crack hunting issue, which means the chill water valve is not steady. It continuously fluctuates and modulates the chill water temperature. In turn, it's modulating the air temperature. So you could see that there is a frequent rise and drop in the temperature of the crack units, and this temperature is reflected in your cold aisles containment as well. So if I'm getting a plus minus 6 or 8 degrees Celsius fluctuations at the crack level, I could get 3 to 4 degrees Celsius fluctuations at the cold aisles containment, which is not good because there are likely chances that you're crossing the SLA limit frequently. So these issues have to be avoided. We call this as crack hunting issue. It's one of the issues that you can identify during heat load test. The second issue that you can identify is many times we have observed that the crack units, if you have N+1 configuration, a crack unit which is very one of the crack unit is loaded to its 100% capacity, while the crack unit which is very next to it is running at 40 to 50% of its capacity. We are expecting that all the crack units should take the load equally. The load should be distributed to individual crack unit equally. But sometimes, practically, you don't get it, and you have to identify and rectify it. So this could go wrong in a heat load test. Now let's go to integrated system test. Now integrated system test is divided into two parts. One is a mechanical failure scenarios, and second is an electrical failure scenarios. What we are trying to do here is, we are trying to simulate what could go wrong in your mechanical systems or your electrical systems. So what could go wrong in your mechanical system, in your chiller plant? The first point is, I could fail a pump through multiple means and see what happens. I could fail a motorized valve, a chiller, a cooling tower, a crack unit. I can even go ahead and fail a temperature sensor which is controlling your chiller plant, or a chiller plant manager which is controlling or creating the logic for the chillers to operate. So I have to try my level best to observe what could go wrong in a data center. How do I do it? Let's take an example here. I have just created an example here. Let's say we have an N+N configuration. You have a source A system of chill water, and you have a source B system of chill water. And then you have crack units which are dual coil, fed by source A and fed by source B. So how do I simulate these failures? The first thing I can do is I can fail the source A chiller and observe that the second chiller comes into picture, and there is no impact on the chill water supply temperature, and the temperature in the data hall is steady. I could also go ahead and fail a pump and ensure that the standby pump comes into picture. However, there is no impact on the chiller system. I could go and fail the motorized valve. And once the motorized valve fails, your chiller fails. So it is important that the second chiller comes into picture, ensuring that there is still no rise in your chill water temperature. I could fail a duty crack unit and see if the standby crack units come into picture. I could actually go ahead and fail the entire riser, source A riser, which is the loss of source A complete, and see a transition from source A to source B without any impact on your data hall temperature. So I'm trying to simulate as many scenarios as possible to identify what could go wrong, and still there is no impact on your data hall. Nowadays, we have also seen that nowadays it's very common to go with buffer tanks, which means if your cooling fails completely, your buffer tanks can help you sustain for at least 4 to 5 minutes, depending on the size of your buffer tanks. So I can also simulate the complete failure of cooling and see how the buffer tank behaves at full load condition. So these are some of the failure points that you can simulate during mechanical failure scenarios. Let's see how you can simulate it for an electrical failure scenarios. So what I can do for electrical system. For electrical system, I can try and fail the source A transformer, source A generator, source B transformer, source B generator. I can even go ahead and fail the complete utility supply, both source A and source B transformers, and see what happens. I can fail a UPS. We can fail the primary source of the crack units, and also try to simulate the external bypass changeover. Now let's see it. How do we do it? Now we have a scenario. We have an electrical schematic here that shows source A system and source B system. Each of this system has its own independent transformer and own independent DG set. What we can do during the integrated system test is we can fail the source A transformer and see that the entire load of source A gets transferred from transformer to DG. During this transfer, the UPS will go into battery mode for a moment, let's say for 30-40 seconds. However, there should be no impact on your UPS output supply. Similarly, I can create a scenario by failing the source B transformer and see a changeover from source B transformer to source B generator. I can create a complete failure of source A by failing the transformer. There are many cases and practical scenarios when you try to fail a utility supply and you are expecting a changeover to DG, but DG fails to start. This could result into complete source A failure. Now here we are expecting that the source B transformer takes care of the entire load and there is absolutely no break at the output supply of UPS. I can do the same for the source B system. I can fail the complete utility supply. I can fail, we can fail the UPS, one of the UPS. See, what happens is, in a normal operating mode, 50% of the load is on source A and 50% of the load is on source B. If I create a failure scenario of UPS, which normally are running at 30 to 33% of its capacity or less than that, if I fail one UPS, the other two UPS should be able to take care of the load. So what we are trying to do is trying to find out the weak links, the worst case scenarios, trying to validate the redundancy level of your data center. Same thing, we can do it for source B. Okay, so what is expected of an IST? So when I'm trying to create so many failure scenarios, it is very important that I'm able to see the status of individual equipments and system on BMS, Building Management System. BMS plays a very important role in an IST. If you're not able to observe the status of any equipment, your IST is failed, because your operation team very much rely on BMS system, and whatever failure happens, your BMS should be able to get the data status immediately. Hence, we are trying to verify the status through BMS. We are trying to verify the temperature and RH conditions throughout the failure scenarios and verify that those are stable and within the SLA limits. We are trying to see if there is no interruption at the DC load. No matter what failure you do, the DC load should be intact and there should be no failure. Sequence of operation, we have to verify the logic, sequence of operation, the cause and effect, the time settings, etc. And finally, you should have no trips, no hotspots, or any major issue throughout the IST. So that is how we carry out an integrated system test. So this was an overview of how a commissioning has to be carried out for a data center. Thank you for your patience. Thank you.
Yeah. I would request Mr. Rajesh Balakrishnan, MD of Stools, to please kindly come on the dais and felicitate Mr. Tushar Vedikar. This is not the end, but just the end of the speakers who have given their valuable time and feedback on all the topics covered today. So I would request first everybody to please give a big round of applause for all the speakers who have made their way and given the opportunity of their knowledge and sharing with all of you people out here.
Before we conclude today's event with so many information, thoughtful information, so many knowledge has been shared, we would like to thank each of our partners. So, Sanjay sir, can you come? No, first we have to give each one of you the phone. Yeah, start with one. Yeah, definitely. You come. Sangeeta ma'am. Sangeeta ma'am, can you please come on the stage, please? Both of us will cover everything. That's right. Table partners will Madam, please come. Mr. Maurizio. Okay. Can I invite Mr. Maurizio to please come on stage? Thank you very much.
For Schneider to sponsor this event.
Yeah. Let's say thank you to them for being a main sponsor for our event. Mr. Balakrishnan from Stools. Mr. Sanyal from Sterling Wilson, can we have you on the stage, sir, please? I would like to request team from Armacell. Team from Zale Abec, India Private Limited. Vikas ji. Vikas ji, one last draw is there, huh? Please. Mr. Rassiwala from AET Flexible Space. Thank you very much, sir. Do we have people from Hilti over here? Yeah, I think she's coming. She's not. Anybody from Hilti? All right, we'll courier them. Thank you very much to all the partners who have been very supportive for this event. Without their support, this event would not have been possible. And now Mr. Sanjay Jadhav will deliver his last vote of thanks.
Yeah, first lucky draw. All right. Who's the lucky one?
All right, now the Aajo Vikas ji. This is the final lucky draw.
It's a big one.
It's a big one. It's a big one. It's the biggest Alexa Echo. So I believe all of you would be willing to have somebody who listens to you at home. So let's see. All right. Can we have a big round of applause, please? Mr. Harsh Nath Pandey from Aditya Birla. Idea.
Not there. No.
No.
Next one. Next one. Idea.
He's going to get an idea now. So it's not a good idea to go away. All right. Okay. Wow, this is really challenging as a committee member. Can we give to the committee member? Can we give to the committee member? Can we give to the committee member?
No. It's gone. It's gone.
I hope. Mr. Bonnie Davis from Natix Controls. Is he around?
No. Let's move. No. Fastest. जो आएगा पहला अभी करा दे। उधर ही कर रहे थे। वही पे बोलते रहे। जियो।
Mr. Raghavendra Heber. Oh, let's welcome him. Sir, come with your Aadhaar card, huh?
Finally हुआ। You are really lucky, yeah. किधर है? Excellent. Congratulations.
Thank you very much. Oh, after 1, 2, 3, 4. Who?
क्या बात है?
अरे विवेक जी का भी नाम आया
विवेक जी का नाम आया।
कमेटी मेंबर करना। चलो जी, वोट ऑफ थैंक्स प्लीज।
चलो। Hello everyone. Wow, what an event. It's really great that this national level program turned out to be very successful. And in fact, I'm thankful to each one of you. You have waited so long and you made this event successful. I'm Sanjay Jadhav and I'm here to present the vote of thanks to the people who made this event successful.
Without your presence, this event would have not been successful. All of you have learned from this event, right from morning till evening. We have learned a lot. I would like to take a minute and thank all of them. First of all, I would like to thank all the speakers. Speakers came from Italy as well as from India. So let's thank all the speakers for their enlightening knowledge on the subject, whatever they have imparted to us. And let's see these highlighted changes of rising technological changes in data centers will help all of us to implement the futuristic technology in our applications. It is really intelligent and thankful for all the speakers who gave such an insightful knowledge to all of us. I also want to thank our chief guest, Mr. Prakash Lohia, as well as Mr. Murari Sinhal, for taking out their valuable time and attending the national event. We are also thankful to our sponsors, mainly Schneider, Stool CHSPL, and Sterling Wilson for sponsoring such a big event and enlightening all the audiences about futuristic technology of data centers. Let's not forget our table partners, Jelabic, as well as Amacell and AD FlexiSpace. And special thanks to Mr. Vikas for making this event a very charming with lucky draw partner. This event would have not been successful without the hard work of ISHRAE committee members. Each one of us, you have seen all the members who were here. Without their hard work, there's a team of, let me tell you, 25 people who worked for this event for last 3 months. And their efforts only have made this event successful. And last but the least, all the audience, hats off to you. Without your presence, this event would have not been happened. And last but the least, did you enjoy the amazing breakfast and lunch here today? Breakfast, I feel few of you would have had, but lunch definitely was good. So let's thanks to Leela Catering for services for their delicious food. It's been a great day. Thank you all of you for making this event successful with your contribution. And let's thank you for all our supporting societies. You can hear IFMA, FSAI, RATA, Awesome, IGBC, IMEP, and IPA. So without these supporting societies, we would have not got the success. Thank you for blessing with your presence. Now I would like to officially end the event with thank you. Thank you very much. Thank you.